Hello, guys. Welcome to the lecture 3 of the Lean 101 series by Ops Knowledge. So, today we'll be talking about the lean tools. So, we have key lean tools, those are 5S, Kaizen, Kanban, VSM, JIT, Jidoka, Poka-Yoke, Andon, Heijunka, or SMED. So there are total 10 key lean tools. Let's go to the next slide and understand about 5S. So as the name suggests, 5S, so there are 5 S's which are defined as sort, set in order, shine, standardize, and sustain. In the Japanese version, it is said Siri, Sito, Siso, Shikitsu, and Shitsuke. 5S is the foundation of visual workplace consisting of sort, set in order, shine, standardize, and sustain. Purpose. Its purpose is to create an organized, efficient workspace that minimizes waste from searching, clutter, or poor maintenance. It was given by Hiroyuki Hirano. So let us understand more deeply what does these 5S means. Sorting means to remove the unnecessary items. Set in order means arranging the tools and materials for easy access. For example, shadow boards. Shine means clean and inspect regularly. Standardize, develop rules to maintain the first 3S. And the sustain means auditing and reinforcing habits through training so that this could have a long lasting effect. Usually, what happens in the plants, a general practice, certain things are implemented, but they are not being followed or practiced for a long term. This is what happens with 5S. But this has been extraordinarily seen in the Japanese companies such as Toyota. You'll be able to see 5S in a very good manner. Let us go to the next lean tool, that is Kaizen. Kai means change, Zen means good. So Kaizen means continuing improvement involving everyone, managers and workers alike. Why is Kaizen there? What's the purpose? So, to foster a culture of continuous improvement, eliminating waste through collective and proactive efforts. So, who gave Kaizen? It's the father of continuous improvement known as Masaki Lamai. Next tool is Kanban. Kanban is a method of regulating the flow of goods both within the factory and outside suppliers and customers based on automatic replenishment through the signal cards. On the right, you could see an image which has around red, yellow, and orange kind of markings depicting the criticality or of the situation. Like there's a fault, so fault is a danger thing. It should not happen. So that's why it is being marked with red color. What's the purpose? To create a pull system that minimizes inventory waste by producing or ordering only what's needed. So let me explain what is a pull system and what's a push system. Whenever a market demand occurs and the company is fulfilling that demand, then it's known as a pull system. But whenever a company on some certain forecasted demand produces the product and get it shifted to the finished goods store and pile it up over there, and whenever a market demand occurs, then it's fulfilled. So then it is known as a push system. You are pushing your goods into the market, and in the pull system, the market is pulling your goods. So it was given by our one and only Taichi Ono, a very renowned name in case of Toyota Production System (TPS). Let's go to the next slide and understand about another tool known as VSM or value stream mapping. So, value stream mapping is a paper and pencil representation of processes in the material and information flow along with the key data. What is its purpose? To identify waste in the entire value stream and design a future state of efficiency. So on the right, you could see not so detailed, but yeah, there's a graph that shows value stream mapping. This is a VSM basically. So what is happening is the information is being transferred from the customer to the production control to the suppliers. Customer will tell how much goods is needed. Production control will be allotted the production order, and for that, raw material will be required. So the information is sent to the supplier. On the bottom end, you could see that there are processes, uh, that is transportation of material. So on the from right to left, you have your information being transferred, and from on the bottom end, you see from left to right, you can see the material is being transferred. So in this way, VSM works. Who gave VSM? So these two gentlemen gave VSM. Uh, Basically, there was a theory that VSM initial roots were from your TPS, but these were the people who formulated it in some words and gave the word value stream mapping. So it became official by these two people. So what are their names? Mike Rother and John Shook are the people who formulated VSM in a formal way. Let's go to the next slide and understand about the next tool, that is JIT or just in time. So just in time is a production system where elements necessary for an operation arrive just at the moment needed with the right quantity, pulling parts through production based on customer demand instead of pushing based on the projected demand. As in the previous slide, I already explained what is a pull and what is a push. So JIT works on the pull mechanism. So what's the purpose? To reduce overproduction and inventory, improving cash flow and responsiveness. So who gave JIT? So yes, the renowned name Taichi Ono gave JIT. Let's go to the next slide and understand about Jidoka or automation. So Jidoka says it is the idea that manufacturers should design equipment to partially automate the manufacturing process and to automatically stop when defects are detected. See, defect detection, if we give that capability to the machine, so our defects would reduce to a very lesser extent. So what will be happening, that the like in the image that is on the right, the evolution towards Jidoka, you could see on the first image that there's a man who's filling up certain components in the machine, and in the next one we are having an automatic feed to the machine. Directly it's being feeded, but there's no defect identifying mechanism. So on the third image, the automatic feed has been given an Andon light. Andon light gives you indication that there has a defect or the machine is not working or the product has a failure. So automatic rejection is being done over there. So a single person could be able to monitor multiple machines while these machines are already producing the product. So that's the whole point of Jidoka. So basically, you are giving a human-like uh, capability to a machine, right? So what's the purpose? So to detect and halt defects early, allowing one worker to oversee multiple machines, as I already told you. So who gave Jidoka? So again, Taichi Ono gave Jidoka. Let's go to the next slide and understand what is Poka-Yoke or mistake proofing. So Poka-Yoke is any mechanism in lean manufacturing process that helps an equipment operator avoid. So avoid in Japanese is known as yokeru, mistakes are known as poka. So its purpose is to eliminate product defects by preventing, correcting, or drawing attention to human errors as they occur. What's the purpose? To prevent errors rather than detect them after occurrence, reducing defects waste. If an error occurs and your product basically gets a defect, so rework has to be done on the product, and reworking has an additional cost. So you are using additional cost of labor and the material that defective material that you would be replacing. So all this will result into increase in the cost of product, which the companies do not want. Either to maximize the product, you have to minimize the cost somehow. Who gave this? So this gentleman gave this concept of Poka-Yoke known as Shigyu Shingo. Let's go to the next slide and understand about the Andon system. On the right side of the image, you could see that this is a system I previously told in the automation that you have an Andon system given to the machine. So this is the Andon system, which helps giving an indication to the operator that there is some problem with the product or the defect identification. So Andon says Andon is a visual feedback system for the plant floor that indicates production status, alerts when assistance is needed, and empowers operators to stop the production process. What is its purpose? To enable quick response to issues, supporting Jidoka. Who gave this Andon system? The one and only Taichi Ono. Now let's go to the next slide and understand about Heijunka principle. So Heijunka principle, also known as level scheduling, it says that it is a form of production scheduling that purposely manufactures in much smaller batches by sequencing product variants within the same process. So what's the purpose of it? To balance workload and reduce inventory by leveling demand fluctuation. Who gave this concept? Again, Taichi Ono. In Heijunka principle, one of my teachers used to tell me, he used to repeat. He used to say that big batches are bad and small batches are good. How much small and how much big will depend from industry to industry. But if you have a batch, then you are producing in a level, a constant production system. Every company wants that. Nobody wants to have an uncertainty or a VUCA environment. Let's go to the next slide and understand about SMED, or single minute exchange of die. SMED is a system for dramatically reducing the time it takes to complete equipment changeovers, separating internal must-stop machine and external can do while running activities to minimize downtime. So let me explain the internal and the external activities. Internal ones are those for which you have to stop the machine, and the external ones are those which you could do while the machine is running. Generally, this principle is explained by the Formula One race. That's why the image of SMED shows you a pit stop of the Formula One. What's the purpose? To enable small batch production by slashing setup times, reducing overproduction. Who gave this concept? Shigeo Shingo gave this concept. That's all for today. Thanks for watching. Have a great day.